Hello good people and welcome back. In this video, we're going to continue talking about data. Specifically, we're going to look at how strings are stored in computer memory, so let's get right to it, shall we? Now we know that text and programming consist of characters. For example, this text hello consists of 5 characters. To represent an individual character in C, we can use the data type char. So let's declare a variable of the type char, named, say, x, and assign it a character literal, say the letter A. Now, to print a character to the printf function, as some of you might remember from the previous videos, we pass %c. As a second parameter, we pass it the variable x. And if we run the code, in the console we will see the letter A. Now, some of you might also remember from one of the previous videos that numbers can be represented as characters. And it also works the other way around, meaning we can treat characters as numbers. So if instead of %c we use %d, we will get 97 in the console. Now where does this 97 come from? Each character in programming has its unique numeric code, so this 97 means that the character A has the code 97. And if we interpret a character as a number, we will get its numeric code. Now one of the systems that is used to encode characters is called ASCII. On the screen you can see the ASCII table, and you can see that the lowercase a has the code 97. Now you might have noticed that this ASCII table has only English letters, in addition to some special symbols I mean. So how about other characters, say the Chinese or Thai or Japanese characters? Well, for that, there is another encoding system called Unicode, which contains over 100,000 characters, including your favorite emoji. Yes, emoji are not pictures, they're actually characters encoded by the Unicode system. Anyways, the bottom line is text and programming consist of characters. Each character has its own numeric code defined by the character encoding system such as ASCII or Unicode. So individual characters in C are essentially numbers, which means that we can do some basic math with character variables. For example, if we add 1 to the variable C, we will get the lowercase b. And if we add, say, 25, we will get, right, the lowercase z. Alright, cool, but how do we represent text that consists of more than one character? Well, we could do something like this. Which will print, what? Can you figure it out by using this ASCII table? Right, it will print hello. And I bet you're like, what? Why? And I don't blame you. Individual characters are not the best way to represent meaningful text. That's why we have strings of characters or just strings. Now, to represent a string, we can use a char pointer. Again, in C, we use single quotes for character literals and double quotes for string literals. And we can print the contents of a string using %s. Alright, so from the previous video, you might remember that char pointers are used to represent the memory location of individual characters. But we can also use char pointers to represent strings, even though a string is definitely not the same as memory address. So what's the deal here? To answer this question, we need to look at another type of data, which is array. An array is simply put a bunch of things of the same data type, meaning a char array is a bunch of characters, which effectively means a string since string is a bunch of characters. Now you can have arrays of any data type, for example int or float, but for now, let's focus on char arrays. A char array, just like the regular char, is a data type, meaning we can declare a variable of the type char array. To declare an array variable in C, we first indicate the data type that will be stored in the array, which in our case is char. We then specify the name of the array variable, say char array, and to the name of the variable, we add square brackets. Now, to this variable, we can assign a string literal, just like we do for the char pointer here. And we can print the string associated with this char array variable the same way we do with char pointers. And we get hello world in the console. Alright, so this variable s is a char pointer, while this char array is a char array variable. Both can be used in C to represent strings. Then what's the difference? A char array is a bunch of characters, and each character in the array is numbered starting from 0. The number of the character in the array is called index. So the first character has index 0, the second character has index 1, and so on. Because each array element has its own index, we can access individual elements and do something with them. To access an array element, we use square brackets after the name of the variable associated with the array. And inside the brackets, we specify the index of the array element that we want to access. For example, we can print the second character of this char array like this. Please note that since the char array is associated with an array of characters, the data type of each individual character is char, so we need to use %c here. Also, just a reminder, the indexing inside arrays begins from 0, so to access the second array element, we use index 1, not 2. Alright, if we run the code now, we will get the capital W, which is the second character of the string. Yes, the space here also counts as a character. Now what else can we do with array elements? We can assign them to separate variables. For example, let's assign to this variable x the third array element. Why don't you try doing that on your own? Alright, so we do something like this. Now remember, when using an already existing variable, we do not need to specify its data type. We only need a data type when we create or declare a new variable. Alright, and now we can also print the character associated with a variable, like this. And now we get the lowercase o, which is the third array element. Next, in addition to printing or assigning array elements to variables, we can also modify them, just like we modify regular variables, like this. So this code accesses the second array element and changes it to the lowercase w. And if we run the code, in the console we will see the lowercase w for the word world. Please note that we changed the array element before we print the string, and that's why when we print the string here, we see the change. Meaning if we place this line of code after printing the string, the change will be applied after the string has been printed, and we won't see the change in the console. Alright, so that's arrays in a nutshell. And again, what we just saw applies to arrays of all data types, not just character arrays. Now, before we move on, let's comment out the code that we have to get it out of the way. Alright, so now let's declare another char array variable. When we did that here, we left the square brackets empty, but we can also type in a number here, say 50. This 50 is now the size of the array associated with this variable sum string, which means that it can store up to 50 characters. Now let's see what will happen if we print this string. Well, nothing gets printed, which happens because we haven't specified the contents of the char array, which we can do the same way as we do here, by using a string literal. And if we run the code now, we will see the text of the string. Alright, so the main point here is that when declaring a string, we can specify the maximum number of characters that the string can contain by typing in a number inside the square brackets. Now why don't you go ahead and print the last character of the string, which is the exclamation mark. So we print the character, whose index is 11. And we get the exclamation mark alright. So the length of the text associated with some string is 12 characters. But here, we specify that the string can contain up to 50 characters. So what's up with the remaining 38 characters? To answer that question, let's try printing the character whose index is, say, 12. And we don't get anything. And if we look at the ASCII table, we will see that there is a null character whose code is 0. The null character is a special character that doesn't get printed, and it acts sort of as a placeholder for another character. So what's the point here? The point is that we can create a string with some initial text and later expand it in size. For example, let's assign a printable character to the 13th character of some string, like this. And now if we run the code, it will print 5. And if we now print the entire string, we will see that we now have a 5 after the initial text. Now please note that 5 inside single quotes is not the same as 5 inside double quotes or 5 without quotes. The first one is a character literal. The second one is a string literal, while the third one is a numeric literal. And yes, even though this string contains only one character, it's still a string. And in C, these two are not the same thing since they have different data types. Alright, so a string is a bunch of characters, and we can use a char array to represent a string. Arrays store individual elements, each having its own index that begins from 0, and we can use the indexes to modify the contents of the array. Alright, but what do arrays have to do with pointers? Well, that is a separate topic which we'll cover next time, when your mind is fresh and no longer overwhelmed by a barrage of information. But before we wrap up this lesson, let's talk a bit about special characters. One of those is the already familiar \n, which, as some of you might remember, represents a new line. One thing that makes this character special is, well, it's a single character, even though it consists of two symbols. Since it's a single character, we can store it using a char variable, like this. And we can print it something like this. Now, the new line character is not the only special one. For example, since we use single quotes for character literals and double quotes for string literals, to treat them as characters, we also use the backslash, like this. So some of you might have realized the backslash sort of tells the computer to treat the next symbol differently from how it would normally be treated, meaning the letter N is normally just the letter N, while the quotes are normally used to define text literals. So what we have here is called escape sequences, and there is more of them. Here's something that you might remember from one of the previous videos. Inside formatted strings, the % symbol is used to represent string parameters. So if you want to include the actual % symbol, you need to use an escape sequence as well. What's worth mentioning, though, is that outside the formatted string, the % symbol is not an escape sequence, meaning we do not need a backslash in front of it. However, inside a formatted string, the % symbol should be escaped, but not with a backslash, with another % symbol. Now, with that in mind, what do you think we should do to represent a backslash as a character? Right, we need to escape it using another backslash. Now here I'm using a string instead of a character just to remind you that A, we can use a character array to represent a string, and B, strings consist of characters, meaning any individual character is a valid string. Alright, and this is pretty much it for this lesson. As usual, to test your grasp on the material covered in this video, you can take a quiz that you can find on our Patreon page. The link is in the description. If you have questions or need help with the material in general, you can schedule a one-on-one meeting with me. The link is also in the description. And of course, don't forget to like and subscribe if you haven't yet, and turn on the bell not to miss the next video. And I'll see you then. Bye!